Hello, maurieo! Diagnostic test questions 36 to 38, the last video. Hello. Welcome to the last video on this series on the diagnostic test. Just 3 questions to go to complete the video. So, without further ado, we will go to Smooth Draw and we'll go to the big screen and let's see if we can get this one done. Okay, right, well the first one here, this is trigonometry. Find the angle theta in the right angle triangle. Yes, there's the right angle triangle there. Okay, oh, the current layer is invisible. I'll go that one there. The right angle triangle, there it is there, right angle triangle. On the right, giving your answer in degrees. Okay, we want it in degrees. Why is my felt pen so big and fat? Oh, no particular reason. Must be just pushing harder. Okay, and that's there, and we're trying to work out the angle. So this, just in the right angle triangle, this is the hypotenuse. And I should be, oh, that's because I'm using the mouse. That's why it was so fat. The mouse. Okay. Now I have to, oh, here it is, using the thing there. So we'll just get rid of that. Oops, no, that we will still want that in degrees. Okay, so this is the hypotenuse, H. Here's our angle theta. It's looking at that one there. So that, for that angle theta, that's the opposite. And this here is the adjacent. Okay, and this is what we want to find. We want to find this in degrees. So we write down SOHCAHTOA. SOHCAHTOA. Tor. If you want to pronounce it perhaps differently. Okay, so we want to find theta, which is either one of these angles here, because it's not a distance. So we'll put a question mark on there, a question mark on there, and a question mark on there. Now what do we know? We know the opposite. Do we know the hypotenuse? No, we don't. So we don't know that. I'll put a cross there. Do we know the adjacent? Yes, we do. Do we know the hypotenuse? No, we don't. Do we know the opposite? Yes, we do. Do we know the adjacent? Yes, we do. So we're going to use the tan. So what we know is that tan, or tangent theta equals the opposite over the adjacent. And in this case, the opposite equals 2. Okay. And the adjacent equals 4. And 2 divided by 4 is 1/2. Or 0.5. Now that's tan theta. Tan of an angle in degrees equals 0.5. So theta must equal tan to the -1, or the inverse tan. Tan to the -1, 0.5. And we want theta to be in degrees. So here's our calculator here. And as we can see, our calculator, I don't know whether it's in degree, what mode it's in. It's not really telling us. So here's our mode. Push the mode key. What's that? Mode. Comp stat table. Or we can go Shift mode, shift mode, and we can push 3, and that tells us, that puts it in degrees. So we go shift mode, we want it in degree mode, we put it into and push 3, and that's in degrees, but it doesn't tell us. I don't think, I can't see where oh, perhaps it is degrees, radians and grads there. Okay, maths, alright, so that's going to be it in degrees. So what we're going to do now is go shift tan, oops, we didn't want that 3 there, I don't know where that came from, shift tan 0 0.5, I'll close the bracket and then go equal, and we get 26.565. now that's degrees, I'm pretty sure. 26.565 is what I got. 26.565, but we want it in 2 decimal places, so that's going to be 26.56 or 57 to be exact. Now on the answer sheet we've got 56. One could argue, I think, as to whether you round up or stay or whatever. It depends on your preference. A 50-50 call. So 26.57, I would accept that, and 26.56. I'll just put that over here, just if anyone was worried. 26.56. Okay. Okay, all right. So now on to the next one, and it's the same thing, theta there, but in a right angle triangle, but we want the answer in radians. Okay, so this is the hypotenuse, this here is the adjacent, and this here is the opposite. So it's pretty much the same as that one up there, the same problem, except it's there. So we're going to go through that bizzo there. So it's going to be tan to the -1 theta equals opposite, which is 2, and the adjacent is 3. Okay, which is, we can do that on the calculator anyway. So let's go to the calculator. Bring up front and center here. So we're going to go, oh, now we're going to change the mode. So we're going to go shift mode, oops, shift mode, no, shift mode, and we'll go to radians, which is 4. Okay, and yeah, I think I can see up there that radians might be highlighted. Okay, so then we go, here we go, shift tan to the -1, shift tan to the -1, it puts in a bracket, we'll go 2 divided by 3, close the brackets, equals, and that gives us 0 before the 0.588. Calculator keeps disappearing. 0.588, and that's radians. Some people in the exam or the test, when they did the test, put degrees. That's not right. This radians is what we wanted. Okay, now we have one more question to do, which hopefully is here on layer 9. If I turn those off, turn layer 9 on, and I think it's up the top here. Here it is. Yes, XYZ, triangle XYZ has a 90-degree angle, so X is 90, so we'll draw a triangle, and that's 90, which we show for that little box, and that there's X, so the angle is X. XY is 29, so from X to Y is 29, so that's XY, 29, and X and XY is 29, Y to Z, this has got to be Z up here, YZ, which we'll draw in, YZ equals 2XZ. So that's 29. Okay, calculate the lengths. So YZ, so let's let's just call that YZ. So there's YZ. That's equals 2XZ. So let's make that there X. Okay, and then that's got to be 2X. Okay, is that right? It's got to be 2X. And then what we have to do is somehow we have to work out the lengths of these sides. Okay, so, well, what do we use? I guess we could use Pythagoras, because we know that I'm going to try using that. 2x squared, not 2x all squared, right? 2x squared, the square on the hypotenuse, is equal to the sum of the squares on the other two sides. So we get 29 squared, all right, plus x squared. Right, so x a squared plus b squared equals c squared, and yeah, that's okay. All right, so working that out, we get 4x squared equals 29 squared, 29 x squared equals 841 plus x squared. Okay, plus x squared. Okay, so I'm going to subtract x squared from both sides. Okay, minus x squared both sides. When we've got a bit more room, my writing is a little bit more understanding. Both sides, which is going to be 3x squared if we take x squared away from there, equals 841. Okay, and then I'm going to divide through by 3. And I get x squared equals 841, which isn't divisible by 3, 841 over 3. Okay, so then I'm going to take the square root of both sides, and I'm going to get x equals the square root of that. Now it's actually plus or minus, that, but the negative value has no sense, so we just use the positive value. Okay, so let's go 841 divided by 3 equals square root of the answer, which is there, equals, and then we push this button here, 16.74. Now the answer's to round to 2 decimal places, so that's x is xz, so that's the small 16.74, 2 decimal places, 16.74. Okay, and then we know from here that that equals 2x, so we just go times 2 equals, we've got to push this here now. There is some way of stopping it from doing that, but I don't know what it is. 33.49. 33.49. Let's just check that. 33.49, 2 decimal places. Okay, they've asked us for 2 decimal places. You could, if you wanted to get real technical, right there. So that's 16.74, and then we can say that that's equal to zx, I think, or xz, doesn't matter, and 2x equals 33.49, and that equals yz. Notice how with 2 decimal places there, if you double that, there should be an 8 there, but there's actually a 9 because we've retained the decimals in the calculation. So that's quite interesting. Okay, well, there we go. Finally, we've got through. We've done it all. They all look pretty good. So it's time for the pat ourselves on the back and say that we have completed the diagnostic test and gone through it. So I'm hoping that that will be of some help to you. That'll give you some worked examples, perhaps an insight into how I think, or how I think. There are other, as I said plenty of times, there are ways that other people think. There are ways that you think that may be better for your circumstances. This has always worked for me. I got most of the things right, but you know, as I say, you've got to meet the challenge and keep going until you have, till you've beaten the challenge, and that you're on to the next thing and adding to your mathematical knowledge, a knowledge that should improve over time. And as you get into your engineering career, they will give you the ability to think in a different way, to think in a mathematical flavour that is just a different way of thinking, that may help in some circumstances. You may not use the maths directly, but some of the thinking skills and some of the skills that you need to go and to research, to find out, and all that are valuable transferable skills that apply to anything from engineering to knitting to archery to all manner of things. So it's all learning, and it's all good learning, and they are building up your repertoire for the future. So, cheers, see you.